Howdy, and so today I'm going to be building and working on my homemade lathe that I started working on, and just go over a little bit of that. So I have a vertical mill that I bought a long time ago and never ever used, but after making a few things with it, I kind of got the bug to build more stuff, and then after I watched a couple of YouTube videos, I saw people building their own lathes, and I thought, you know what, that might be fun to try that. So that's what I ended up starting to work on. I'm still in the middle process of doing that, and I'll have a larger video that shows all of that. But today I'm working on just building a simple NEMA 23 stepper motor mount for the screw drives on the lathe. And so I'm going to go over a little bit about that and everything that goes into doing that. Now, I'm also going to go over the components of the lathe just because I haven't done that before, so everybody can see what I've already done on it. Let's go ahead and switch this around so I can actually show everything related to the lathe. So I've got the headstock here that I built, and I just used a piece of rectangular steel tube to put that on, along with two cushing bearings that are parallel to each other, along with a 3/4 inch rod, a pulley, and then a 5-inch disc that I'm still shaping into the back plate. I'm almost done with it though. I just stopped to work on the stuff related to the automation for the CNC. So this was the first bracket I made. I'm actually going to replace this one. This one works okay, but it moves around a lot, and I like the other design better. So I'm going to go ahead and knock out two of the new design, which I'm about to show you guys, and we will go from there. And then as far as the top part goes, I bought the cross slide for the tool holder, but everything else I made on here. So I just used a piece of plate steel, cold rolled for this. I still need to finish it, so it's all going to come off and get painted. And then I used aluminum for my bottom sled, which obviously doesn't have to be painted. The interesting thing is these rails here weren't the same height as the screw drive, even though I bought them in the same kit. So I ended up having to shim this up a couple pieces up, which I just did with some bar aluminum. Now, aluminum's not cheap, so getting something that actually fits would be better. But in this case, I didn't want to try to figure out what to do differently, so I just used some bar aluminum and shimmed it. And then this side, I did the same thing to it. I didn't shim anything up, but I needed this extra piece put on here. This wasn't long enough when I first finished it up. I needed this extra piece so I could connect into the screw drive. So this was a mistake I made early on in design. I was able just to fix it by putting a cantilever piece out that's screwed in. It's held on pretty darn well. It's held on by this piece and by these two pieces over here, and then also supported by this huge steel bar that's right here as well. So I don't anticipate I'll ever run into issues with that. It's all running on a sled that runs 24 inches long on these rails. And I got all this on Amazon. I'll later, when I post the overall video, I'll post all my parts list as well as what I purchased and how much it all costs. I don't know exactly how much it all was off the top of my head. It wasn't cheap, but it wasn't super expensive either, way less than buying one. So what I'm working on is this right here. This is obviously not going to work the way it is right here, but what I'm working on is this piece right here. I fabricated this piece yesterday. I originally made it in Adobe Illustrator and then used a G-code to Illustrator to G-code program to move it over. But this piece right here isn't going to work because there's not enough clearance here. So I'm actually going to make another one of these for this side, move this one to over here, and this one is fine the way it is for over here. But for over here, it needs to be self-tapping because there's no clearance over here to work with. Whereas over on the other side, I have plenty of clearance to work with. So this will move over to here, and then I'll build a new one of these, and I'm going to use my mill to do that. And as you can see, there's a total of 8 holes in this, 9 actually if you include the center hole for the thing. So getting all these in here precision-wise without using some type of program to do it isn't impossible, but my skill set is low, and using automated equipment such as the CNC stuff makes it easier for me. So originally trying to figure out what I'm going to mount this to was one of the things, but inside of the screw drives there's a little bracket, and I just made a little drawing of it. But it's a little square, and It has 4 screws in the middle, uses the M4 screw, and so I just use that as the mounting mechanism. But in order to do that, I have to actually create a pocket for that square to go into in the actual aluminum that I'm going to be cutting into. I'm using 1/2-inch aluminum square that I'm going to make into a square, and that needs a total of 9 holes put in it, 1 in the center, 4 around for the pocket, and then 4 for the actual NEMA 23 motor mount. So anyway, so this is what it looks like in Adobe Illustrator. So here it is in Adobe Illustrator. Not very interesting at all to just look at. So I'm just going to go over real quickly how I did it. It's a 60 millimeter square here, and then these are centered on the edges. So what I did originally is I made a box, made another box, made a box, and then a circle for the square. So I'm not going to be able to do exactly everything again, but just briefly. When you take the square tool and you click, it asks you how big you want it. And you can type in anything you want there. So if you want a 60 millimeter square, you just type in 60 millimeters by 60 millimeters, and it makes you the box. And as you can see here, if I go and grab the tool over here and bring this over, this box is 60 millimeters, or just right actually under that. It looks like maybe it's 58 millimeters. But as it ends up though, I need to actually make the box a little bit bigger on the next build I'm doing, because the tool width is, this is the outer dimension that I need for the bracket that I'm building, or the plate. And so when the tool comes in and cuts this, it actually cuts it too small, and I actually need it to be a little bit bigger. So I'm actually going to make it 64 millimeters, so I'm not going to actually use this piece at all. And I'm going to go in and hit the box again, and I'm going to tell it to do a 64 millimeter. Let's try that again. 64 millimeter by 64 millimeter. And then I'm actually going to take this and just center it on that. Now, I'm not getting these holes cut completely for me. All it's doing, I'm doing kind of a scratch pass on this and getting all these holes marked. And then I'm going back with my drill press and actually drilling them. So I use the CNC machine to center them and drill through completely, but then I use a drill to finish them out on all of them, except for this one here. I went ahead and just used a 1/2-inch 2-flute end mill to take that. Anyway, so what I'm going to do here is I'm just going to move this slightly over, and I do that just by selecting it, and I can just hold down the arrow keys to do this. I don't need to move it all. And then I'm going to take this one up here and move it down. And it's going to cover it up because it's the way the Illustrator works. But I'm just going to go to transform, arrange, I'm sorry, and say send it back. And now it's in the very back of everything. And it looks like I put it right dead in the center where it needs to be. So now I need to get rid of this one though, because I don't want it to make that line on the CNC. So just by selecting it and erasing it, I can do that. Now when this comes in and cuts, my tool width can be up to about 6 millimeters bigger than the actual width of it. Now the size of this is not super important. If it's 60 millimeters or 62 millimeters or 59 millimeters, it's fine. The main thing is that these holes have to be in the exact right place. Otherwise, the motor's not going to mount. And these have to be in the right place. Otherwise, those holes aren't going to match where they need to be. And this needs to be in the right place. Otherwise, it's not going to allow enough room for the screw drive to get through. Okay, so I'm using a script for this, and so for the script, I'm just going to come down here to scripts, and I'm going to go export to GCODE version 5. It just comes up with a screen here, and it basically asks you what you want it to do. Now, I had the feed rate for the tool at 20 and the seek rate at 200. And what I found is that some of the cutting is going at 200. So what I'm going to do is 50 works for both just fine. And so I'm going to change both of those to 50 and call it even. I'm going to go ahead and save those settings. And that's what we're going to do there. And then as far as the G-code off and on commands, I have those as 5 and 0. And so that's where we're going to set those. Now you have to put colors in for this. Obviously I don't have any colors, but I used 0 and F, and then I made up a third color. And then you just hit generate G-code, and then it'll generate the code. Oh, it's done actually. So that was pretty quick, and it's in a test folder. So let's go to that, and let's see what we got here. Yep, it's the third one here, and I want to open that with a text editor. WordPad's fine. And you can see here it generated the G-code for me. Anyway, so we'll run this. Now, one of the things I do like to do is with these files is you can go ahead and try them out on a simulator, and there's plenty available online to do that with. But if you just search G-code simulator, and the one I've been using is this one here. I like the way it works. It's easy to use. You just come up here and click the open on it. You go to your test G-code file and go to the NEMA 23 motor mount 3, which is the one I just did. And you can see here when you zoom out, it's got it set up right here on the edge. Now, it's hard to see, but it's there. And then you can just come over here and click the play button, and it's going to walk through it. And so it goes through everything. So just by watching this run, you can see that it's going to cut the job out on the CNC machine just fine. And so that is done. It takes way longer to actually cut it into metal, but we know it's going to work because of that. So here I am in the workshop, and I'm getting ready to start off on building the piece on the CNC machine. So inevitably, when I designed this, I originally tried to make this where I could get 2 of these out of this one sheet. And I was hoping I could do that, but I couldn't actually get that. I ended up with this leftover, which, as you can see, is less than half of that's available. So I'll have to I'll save this, obviously. It's still an expensive piece of aluminum. It's 1/2 inch. And there's probably something I can make out of it later. I just don't have anything to make out of it right now. So that's one of the things that was a little bit frustrating when I designed this. I was hoping to get 2 out of it, just based on the size and measurements that I was going to need. But I underestimated that, and that was not the case. I couldn't get that out. So we're going to be using the CNC machine to do this with. And so what's interesting about this is a Harbor Freight mini mill. And I've upgraded this. There's a video on what I did here. But I basically didn't have enough power that I thought I didn't have enough power. So I went and upgraded to a 3/4 horsepower motor, about 500 watts. And it's been amazingly better. Right now I've got a little 1/2 inch 2-flute end mill on that. I need to take that out, and I'm going to put in a 1/8 inch end mill for the cutting we're about to do. So here's the final piece when it was done, and it's not completed yet. I still need to trim off up here, here, and here, and then tap these screws here, and then these screws right here I need to drill out to a little bit bigger size. But overall it's done. You watched the time lapse on it. Part of the time I was there, it was a really fast time lapse, so you couldn't tell. I actually wrote the G-code to do this pocket. What I did to do that is I just started 0 here in the corner, and I did over here to this point, and then down to this point as well. Obviously this is square, so the X and the Y are exactly the same, but I went ahead and measured them just to make sure, but they were, so that's all good. Also, I drilled a hole through here manually as well, But all the downward hole movements you see, those were all manual. But the carving of this pocket was a G-code that I wrote while y'all were watching on the time lapse, and then this was a manual as well. And I did that last pass manually. Anyway, this keyboard that I was using during the thing, it's just a $11, $12 keyboard from Amazon. I'll include a link to it. I really like it a lot. It just has a little dongle there that comes inside the battery compartment. Doesn't use any standard batteries. It has a rechargeable one. So I don't know how long that's going to last, but so far I've been really happy with it. To move the axes, I just use this, and to move the Z axis up and down, I use these two buttons. So we finished up the piece, and as you can see, it turned out really nice. Looks just like the Adobe Illustrator file that I had made. It is going to be able to be used on the camera mount. This was all done by the Adobe Illustrator and then the G-code conversion, except for this pocket and then the drill through holes as well. And then of course the final trim I did manually as well on it. I did do some finish passes over it to make it look nicer. But those are not necessary, but definitely makes it look nicer. And then I took a bench grinder wire brush to the back just to get off some of the sharp edges and make it smooth. But as you can see, the piece turned out really well. The time lapse is deceptive. This did take a couple hours to make. Anyway, I hope this was helpful. Please like and subscribe to my videos, and I'll keep trying to get better. Leave comments about things I could do better on my video. I will definitely incorporate them into the next one. I do know that there are a lot of different ways to do this. One of the things I just recently learned, for instance, is using a 2-flute end mill is what allowed me to make this a lot faster than using a 4-flute end mill. So I'm still learning machining, and I still have a lot to learn on my lathe build's probably not great. I literally did it right out of my head after watching a few people build their lathes. So it's definitely something where I can definitely, and I'm willing to take your feedback and get some input on how to do stuff. And voila, or voila, as it's properly pronounced. There is the motor mount and the plate that we made earlier. And then the coupler, and then I used these aluminum tubes, which are very beefy, to provide support. Anyway, super sturdy, and as you can see, it's working very well in controlling the Z-axis. I took off the old bracket for the Y, and I'm going to put that one on as well. And this is the CNC Linux that I'm using to run this with. Anyway, thanks. So here's the second one. I cleaned up the second motor mount quite a bit. I trimmed the edges on it, and then also deepened the pocket so it matched the other one. So now I just need to cut the supports for it and measure it up. So I'll measure those, cut them to length, and then install the other NEMA 23 stepper motor. So I finished up, and now the motor mounts are completed, and the NEMA 23 high torque motors are all attached up to the lathe. Next step is going to be to finish this back plate and then put the chuck on, and so we'll get busy started to do that. Now that I have these stepper motors on, I'll actually write some G-code to finish that up for me. Anyway, I appreciate everybody's time to watch my video. Again, please like and subscribe, and I will have a little thing here at the end here that shows this installed.